In our last video on section 3-1, we talked about pairs of angles that are formed by two lines and a transversal, and we named those pairs. In this section, we're talking about how those angle pairs are related, especially when the two lines are parallel. We'll introduce the corresponding angles postulate, the alternate interior angles theorem, the same side interior angles theorem, and the alternate exterior angles theorem. Okay? We'll also talk about how to prove these theorems and other theorems that use these theorems. And we're covering two geometry standards, G.1.1, that you can identify and give examples of theorems, and G.6.4 that you can prove and use theorems that use the properties of parallel lines cut by a transversal. All right, first we're talking about the corresponding angles postulate. Okay, now it's a postulate, which we talked about in section 1-2, that it's an accepted statement of fact. Okay, something that we take to be true without requiring a proof of it. Okay, and what the corresponding angles postulate says is if a transversal intersects two parallel lines, they must be parallel, then the corresponding angles are congruent. For example, 1 and 5 would be congruent, and they look to be congruent. Okay, that 2 and 6, for example, all the pairs of corresponding angles are congruent if the lines are parallel. Okay, now in simpler terms, if the lines are parallel, then the corresponding angles are congruent. Okay, let's use the corresponding angles postulate to find a missing angle. Okay, we're going to find this angle. Okay, so the angle that corresponds with that one in the upper left-hand part is this angle. Okay, so by the corresponding angles postulate, they're congruent, and this would also be 145. Okay, the alternate interior angles theorem is a theorem. Okay, so we actually would need to prove this one before we can use it. And the theorem states that if a transversal intersects two parallel lines, again they must be parallel, then the alternate interior angles are congruent. Okay, for example, 3 and 5 would be congruent because they're alternate interior angles and the lines are parallel. Okay, in slightly simpler terms, if the lines are parallel, then the alternate interior angles are congruent. Okay, let's use this theorem to find a missing angle. Okay, we're going to find this angle, and by the alternate interior angles theorem, then the alternate interior angle to this one, so this angle and this angle, would be congruent. Okay, so it's congruent to 82 degrees, and so this angle would be 82 degrees by the alternate interior angles theorem. The same side interior angles theorem is slightly different. Okay, again, the lines must be parallel lines. Okay, but the same side interior angles are supplementary. Okay, so for example, 4 and 5 are not congruent because one is acute and one is obtuse, but they're supplementary, meaning they add to be 180 degrees. Okay, in slightly simpler terms, if the lines are parallel, then the same side interior angles are supplementary. So let's use this theorem. By the same side interior angles theorem, these two angles will be supplementary. Okay, so the question mark would have to be, let's see here, 180 minus 110 is 70. So this has to be 70 degrees. All right, our last theorem is the alternate exterior angles theorem. Again, if the lines are parallel, they have to be parallel, then the alternate exterior angles are congruent. So for example, 1 and 7 are congruent by this theorem. Okay, in simpler terms, if the lines are parallel, then the alternate exterior angles are congruent. Okay, let's use this theorem to find an angle, this angle. By the theorem, the alternate exterior angles are congruent. So these two angles are congruent, and so the missing angle will be 120 degrees. Okay, now some more application. What are the measures of angles 3 and 4, and what theorems or postulate justifies each answer? Okay, I'll start with 3. Now, if you look at 3, and the only angle we know is 105, and how are those two angles related? Well, they're alternate interior angles, and so by the alternate interior angles theorem, they're congruent. So 3 is also 105 degrees. Angle 4 and 105 are same side interior angles, okay, because this is now the transversal, okay, and L and M are the two lines, okay, so they're on the same side of the transversal and on the inside of L and M, and so by the same side interior angles theorem, they're supplementary, and so angle 4 is 75 degrees, okay. Now for 3, this was the transversal, and so it changes based on what angles you're looking at. Okay, and down here, it says use the diagram in problem 3. What is the measure of each angle and justify each answer? We will do just a few of these so you get the idea. Angle 1 in A. Angle 1's right here, and looking at this, I would probably talk about angle 1 and 4, how they are related. And angle 1 and 4, I would take L as the transversal, and so 1 and 4 are on alternate sides and on the interior of P and Q. And so by the alternate interior angles theorem, they're congruent. And so 1 would be 75 degrees. Angle 2, okay, I would again use 2 and 4. Okay, so L is my transversal and P and Q are the two lines that are parallel. Okay, and so by the corresponding angles postulate, angle 2 is also 75 degrees. C, angle 5. In angle 5, I'd probably use M as my transversal and P and Q as the two parallel lines. And angle 5 and this 105 angle are corresponding. And so angle 5 would be 105 degrees. Okay, I hope you see how you can do that for all the angles that are listed. Now here's a summary of all the postulate and the 3 theorems that we talked about in this section. Okay, again, they always start off with the lines are parallel. The lines must be parallel for us to make these conclusions. Okay. Now let's actually talk about how to prove one of these theorems. Okay, we'll be proving the alternate interior angles theorem. Okay, so keep in mind that we can't use that in our proof because we're proving it. Okay, now let's talk about the theorem is that if the lines are parallel, then the alternate interior angles are congruent. Okay, that hypothesis part, if the lines are parallel, is where our given comes from. Okay, the lines are parallel. The then part, or the conclusion of that theorem, is that the alternate interior angles are congruent. So in our prove statement, 4 and 6 are proving that they are congruent. Okay, so before we get into writing this proof, I think it's helpful for us to pause and ask ourselves, why should this be true? Okay, and I know that you probably want to say, well, it's because they're alternate interior angles and they look to be congruent. And I agree with you that they look to be congruent, but in a theorem, in order to prove the theorem, we need to be able to justify using deductive reasoning why that's true. Okay, now keep in mind that we can use the corresponding angles postulate. Okay, now although we haven't proved this, it's a postulate, and therefore we can use it without proving it. Okay, so if you look at the diagram, which angles are corresponding angles? Well, 6 and 2 are corresponding angles, so by this postulate, we know that they are congruent. Okay, I also can look at 4 and 2 and think about how 4 and 2 are related. And 4 and 2 are vertical angles. And we have a theorem about vertical angles, that they're congruent by the vertical angles theorem. Okay, so here is the proof. I will always begin a proof with my given. So the first statement is L is parallel to M, and the reason is it's given. Okay, the next statement I'll make is about 4 and 2. Angle 4 is congruent to angle 2. And the reason is, like I mentioned before, the vertical angles theorem. Okay, the next statement that I'll make is about 2 and 6, that angle 2 is congruent to angle 6 by the corresponding angles postulate. Okay, now the thing I'm trying to prove is that angle 4, is congruent to angle 6, okay? And that's true by the transitive property, that 4 is congruent to 2, and 2 is congruent to 6, and so 4 is congruent to 6. Okay, now let me point out the fact that I did not use the alternate interior angles theorem in any of my reasons, okay, because I'm proving that theorem. The other thing to point out is that my last reason is not proof. Okay, I've had students that want to write down for the last reason is proof. I think it's because the first statement, the reason is given, and they're trying to use the word prove in there. But we will never have prove or proof statement as our last reason. Okay, and this is the theorem, the proof of the alternate interior angles theorem. And we could prove all of the theorems, and there may be questions like that on, in class or on quizzes or tests. Okay, this is not a theorem, okay? So we can use any of our postulates or theorems that are in this section as we're proving this, okay? And the theorem states that if A is parallel to B, okay, that's already drawn in on our diagram right here. If they're parallel, then angles 1 and 8 are supplementary. Okay, these two angles are supplementary. Okay, so we'll first talk about why could this be true. Well, we don't have any theorems that relate 1 and 8 directly to each other, so I'll need to use either angle 5 or 7. Okay, so let's see here. 5 and 1, how are they related? They are corresponding angles. Okay, so by the corresponding angles postulate, they're congruent to each other. Okay, the other thing to point out is that 5 and 8 are a linear pair. Okay, and we have a linear pairs theorem that states that 5 and 8 are supplementary. Okay, so I think that's how the proof will go, is that 1 and 5 are congruent, and 5 and 8 are a linear pair, and so 1 and 8 must also be supplementary. Okay, we'll also probably need to use some algebra to state that they're supplementary. Okay, so that's kind of where we're going in the proof. That's why it should be true. So here's our proof. The first statement is our given. A is parallel to B, and the reason is it's given. Okay, our next statement is that angle 1 is congruent to angle 5, and that's by the corresponding angles postulate. Okay, now we will need to use some algebra in this proof, okay, to say that 1 and 8 are supplementary. So what does it mean for these two angles to be congruent? It means that the measure of angle 1 is equal to the measure of angle 5. Okay, and I'll say the reason is the definition of congruent angles. Our next statement is about the linear pair. Angle 5 and angle 8 are supplementary. And that's by the linear pair theorem. Okay, now what does it mean for 5 and 8 to be supplementary? It means that the measure of angle 5 plus the measure of angle 8 is equal to 180. And that's by the definition of supplementary. Okay, um, let's see here. Now, we have these two statements. We know some things about algebra, that if angle 1 and 5 are, sorry, if these two things are equal, then I can plug in the measure of angle 1 into this part of the equation. And so I'll do that. The measure of angle 1 plus the measure of angle 8 is equal to 180. Okay, and that's by substitution. Okay, now if you look at statement 6, that's exactly what this is. And so I can say that angle 1 and angle 8 are supplementary. Okay, and the reason is again by the definition of supplementary. Okay, so here's the proof. I know it's a little more complicated, but before you start each proof, think about why that should be true. Okay, and when you're proving things to be supplementary, you may need to use some algebra, some substitution. That's a really handy tool that we have. And so I hope this proof made sense. In this section, we talked about how angle pairs are related when two lines are parallel. Okay, we talked about the corresponding angles postulate, the alternate interior angles theorem, the same side interior angles theorem, the alternate exterior angles theorem, and we also proved one of these theorems and another theorem that we needed to use one of those theorems in.